Common logarithms. Why do we care? Well, remember when we first started looking at logs, what was the reason? It was, what if we had something like 3 to the power of x equals 7, and we wanted to find out what x was. We want to solve for x. We said that, hey, logarithms might be a way to help us do that. We just convert from our exponential equation into the logarithm form of the equation, and we do it like such. We use something called the Weingarten rule, and it went a little something like this. We'll write log, and then base 3, we start with base 3. That's like Go on the Monopoly board. And then we go from there to the 7, so log base 3 of 7. And then next we would write equals x. And by converting from exponential form to log form, what we did was we got x all by itself, and that's the goal of solving equations in algebra. Unfortunately, when we solved this equation, what we got was log base 3 of 7. And we really had no idea what the value of log base 3 of 7 was. Now, we talked about a number of different logarithms that we could figure out in our head, and we did it based on this idea. We said that if we knew that 2 was raised to some power, and that was equal to 2 raised to the power of 5, what we said was, well, if these two exponentials are equal and the bases are the same, then the exponents must be the same. So we said x must equal 5. So that was cool. So then we took a look at logarithms like this, log base 3 of 9. And one of the things that we said about logs is that this whole thing, the log base 3 of 9, is actually just an exponent. And the exponent that it is the power of 3 that gets us 9. That's exactly how we figure out what the value of the whole log is. We say, what's the power of 3 that gets us 9? And if we know the answer, then we know the value of this entire statement. Let me go ahead and circle it. So again, if we know what the power of 3 that gets us 9 is, then the stuff that I just circled, that whole thing, is that value. So one of the ways we could work that out is we could do something like this. We could say, well, 3 to some power equals 9. And then we could rewrite the 9 as a power of 3. So 3 to some power equals 3 to the power of 2, because that's what 9 is. And so therefore we could figure out, well, it equals 2. Yippee, yahoo! Turns out that if the power of 2 is what we need to raise 3 to get 9, then this whole thing is equal to 2. And so we can just write 2 right there. So all of this was fine and dandy. You know, this whole thing about exponential equations and this whole thing about figuring out the value of the log. But it was all easy because we know what power of 3 gets us 9. There's a problem when we have a base 3 and it's log base 3 of 7. We don't know what power of 3 gets us 7, at least not right off the top of our heads. And there's an awful lot of logs that are like this. So it'd be kind of nice if we could get an exact value, if we could get a value for this. And it turns out our calculator will help us. So why do we care about common logarithms? It's because common logarithms are the most commonly available way to compute a log on your calculator. So let's take a look and see what I mean. Most scientific calculators have a button that looks like this that says log. And when you see a button that looks like this, that means that it's going to let you calculate a log. So let's see how it works. So what we're going to do is we're going to try to calculate the log of 10. Now, something real important I have to tell you, it's this. Let's put the calculator away for a minute. Common log, I'm just going to abbreviate, but you can write it out if you need to make sure you remember this. Common log simply means that we have a log with base 10. That's it. That's all that common log means. Common log means log base 10. So when we see something like log of 10, of the number 10, and we see nothing here, That's a common log, that's a common logarithm, and we can assume that the base is 10. Sort of like way back when we had, remember when we looked at nth roots? And we said, hey, this thing is a square root, and now we have these new things called cube roots and fourth roots and fifth roots and all kinds of roots. But we started writing numbers here. Well, it turns out there was always a number that was implied right here, we just never wrote it, and that number was 2. Common log is a little bit like that. When we write log without any number here for the base, we assume that that's a 10. When we write this square root sign with no, or I should say this radical symbol with no number here, we assume it's a 2. When we write log with nothing here, we assume it's a 10. So common log means log base 10. Okay, let's get back to our calculator. So with that idea in mind, if I was to punch in 10 into my calculator and then hit the log button, it's going to do something. It's going to evaluate and give me a value. And before I hit that, I want you to think about it for a second. I'd like you to think about, if I have log base 10 of 10, what do I expect to see on the calculator? Hit pause if you need some time to think about it. Again, something that I've said to you folks for a while now is that it's okay to use a calculator. And in fact, when you use one, make sure you have a darn good one, you know, like a graphing calculator, certainly scientific, and you're going to use it on the SAT. But when you're using that calculator, make sure that you have some expectation as to what the result is going to be. If you don't, the calculator really is useless because it can spit out answers and you'll have no idea whether they're right or wrong. So right now, take a moment and pause the video and see if you can figure out what log base 10 of 10 is going to equal. Okay, I'm hopeful that you took some time to do that. Let's take a look and see. Drum roll, please. Here we go. 10, I'm going to go ahead and take the log of 10, just like I'm writing over here. Let's see what the result is. Boom. Log of 10 is 1. Again, this is the common log because there's no base shown here, and we get the 1. I hope that's what you guessed, is that this would turn out to be 1. Okay, so now we have a lot of work to do because I want to show you a lot more interesting stuff about common logs. So what we're going to do is we're going to write out a variety of common logs that you could take. And for instance, I'm going to start off with one that we already looked at. So this will be log of 10. And by the way, you don't always have to write parentheses. You can just write it as log of, and I'll write the next one as log of 100. And then I'd also like to know what is log of 1,000. And just for giggles, we'll do log of 10,000. Now, one thing that I want to point out when we are writing out the log and the number is this 100 is not an exponent of log. Log base 10 of 100, that entire thing is one exponent. But this, the way that this should be written is the 100, I know I haven't written it very neatly, this is probably my best version right here, but the bottom of all those guys should line up kind of with the bottom of the L, O, and G, all right? This should not be raised up, and these numbers should not be smaller than this log, okay? To me, it can be confusing to students if they think of this number as an exponent, especially since log itself has no value. It's not a number, and therefore it cannot be raised to a power. Log is a function. It does things to numbers. So for instance, log base 10 of 100 does something, and it gets you a result. And the result that we end up getting looks like this. Actually, I'd like you to pause the video, and I'd like to see if you could write out what each of these is equal to. So if you had to do log base 10 of 10, what do you get? Log base 10 of 100, what do you get? Log base 10 of 1,000, what do you get? Log base 10 of 10,000, what do you get? Don't cheat. Don't use your calculator. Do it in your head. After you do it in your head, you can then do it in your calculator. But for right now, I want you to use your brain. See if you can figure these out. Pause the video. Okay, I'm hopeful that you paused the video and that now you're back. And I'm hopeful that you got a 1 for this guy, and a 2 for this guy, and a 3 for this guy, and a 4 for this guy. Now, One of the things I want to clue you into is the idea that logarithms are a way to make math easier. They're a way to take very large numbers and make them into small, easy to work with numbers. And that's why we use logarithms for things like the Richter scale and the pH scale, is because when you've got very large numbers, like 10,000 or 100,000 or a million, it'd be really nice if we didn't have to always write out 100,000 or a million. I mean, what if we could just write 5 or 6? Makes it so much easier. And that's why it's used in the Richter scale, because earthquakes can get really, really big. And it's just much easier to refer to them as 1, 2, 3, and 4.0 rather than 10, 100, 1,000, and 10,000. Now, here's where things are going to get a little tricky. And for those of you who are taking notes, I'm hopeful that you can add this over here to the left in front of these. If not, it's okay later on, but it'd be nice to put these in order. But we're going to try a few more. What if we have something like this? What if we have log base 10 of 0? Well, actually, let's do this. Let's start with maybe just 1, see what you can do with that. And then we'll try log base 10 of 0.1. And again, you don't need to have the parentheses, so we'll try log base 10 of 0.01. And again, just for giggles, just so we make sure we're getting the pattern, log of 0.001. What I'd like to know is what each of these equal. And again, don't do it in your calculator. I want you to try it in your head. At least if you want to get a decent grade on the next test, this would be a technique that I recommend you try using. Push yourself, test yourself. See if you can figure out in your head what log base 10 of 1 should be. In other words, what power of 10 gets me 1? And then same over here. What power of 10 gets me 0.1? What power of 10 gets me 0.01? And what power of 10 gets me 0.001? Now, I will give you a little hint, but before I give you the hint, pause the video and try to see if you can figure this out. Okay. I'm hopeful that you paused the video, and so now I'm going to give you a little hint, okay? For the 0.1, I want you to remember that 0.1 can also be rewritten as 1 over 10. Now, if that hint helps you, I'd like you to go and try to write all of these. I'm going to give you another hint in a minute, but go ahead and pause the video and try to figure out log base 10 of 1, log base 10 of 0.1. If you can do the other two, that'd be great. If not, in a second, I'm going to give you another hint. Okay. Okay, hopefully you paused the video, and now we're back. So I'll give you another hint in case you need it. 0.01 can be rewritten. Now, you probably wrote it as 1 over 100, and maybe that helped you. But if that did not help you, remember you could also write it like this: 1 over 10 squared. And I'm going to do a couple more things for you if that first hint did not help. You can also write 1 over 10 as 10 to the power of negative 1. And you can also write 1 over 10 squared as 10 to the power of negative 2. Now, what we're saying is that log base 10 of this is log base 10 of 10 to the negative 1. And log base 10 of this is log base 10 of 10 to the negative 2. So, again, before I write what these are, I'd like you to go ahead and pause the video and see if you can write all these in. Go ahead and pause. Okay, again, I'm hopeful that you are with me and that you wrote all these in. If that is the case, then hopefully we'll see if we agree. If you didn't get it, that's fine too. I'll explain in a sec. So 10 to the power of what gets you 1? Well, 10 to the power of 0. Again, you could try it on your calculator, not the log thing, but try doing 10 to the power of 0 on your calculator. If you do, you should get 1, okay? And so, oops, I'm sorry, I shouldn't be writing all this here. Let's get rid of all that. I should have written it over here. 10 to the power of 0 gets us 1. And so therefore, 10 to what power gets us 1? Well, 0. That's what it is. Okay, and then 10 to what power gets us 10 to the negative 1? Well, if I had to raise 10 to some power to get me 10 to the negative 1, it would be the power of negative 1. Are you kind of with me on that idea? If there was a little 10 here and I raised it to the power of negative 1, I would then get this, which is 10 to the power of negative 1. All right, let's keep going. For the next one, again, you could pause at any time and try these others, but I'm going to just go ahead and say this guy right here, this should be 10 to the power of negative 2 to get us 0.01, and this should be 10 to the power of negative 3. Now again, what I'd like to point out is when we go from a very, very small number, this is 1/10, this is 1/100th, this is 1,000th. Okay, when we go from a number that small, 1,000th, to 10,000, that's a really big change in numbers. But when we take the log of those numbers, look at how little change there is. We simply go from negative 3 to negative 2 to negative 1 to 0, 1, 2, 3, 4, all the way from 1,000th to 10,000s, okay? That's a huge change, and logs sort of help to make everything nice and compressed and simple. Another thing that's kind of interesting, well, I'll leave it at that for now. Oh, well, let me tell you this. These numbers, the 0.001 and the 10,000, the changes that we see are actually exponential. But when you look at how these blue numbers have changed, the negative 3 to the 4, what we're doing is we're going up in a linear fashion. So what the log is doing in a very cool way is it's converting numbers that are actually growing exponentially into numbers that only grow in a linear fashion. It's sort of like taming a lion. Anyways, just thought I would throw that out there. I think that's all I got for this video, and I'm hopeful that I'll give you more in another.